Hello, everybody. My name is Mirko Novakovic. I am co-founder and CEO of Zero, and welcome to Code Red. Code, because we are talking about code, and Red stands for requests, errors, and duration, the core metrics of observability. On this podcast, you will hear from leaders around our industry about what they are building, what's next in observability, and what you can do today to avoid your next outage. Hello, everyone. Today I have Birol Yildiz at my show. Birol is co-founder and CEO of ilert, incident and on-call management, and founded in Cologne. And I'm really happy to have you on my show, Birol.
Thanks for having me, Mirko. It's a pleasure.
Before we talk about Cologne and that we are very close with the companies, I always start my podcast with a question, which is, what was your biggest Code Red moment?
I had a few, and we're an incident management company, right? So we experience a few of these moments. But I generally tend to suppress negative thoughts. But there's one moment I remember vividly, which is an outage of our web platform and mobile apps, which lasted about 15 to 20 minutes. And the reason why I remember it vividly is because I was on vacation back then. I was having early breakfast with my kids, and then I was return to the room and I see these messages on my phone from our status page from the engineers. We're having an outage, right? The reason why this was very intense is we pride ourselves of being a very reliable platform, right? Because we need to be up when all of our customers are down. And in 50 minutes, that's pretty long, right? It's really long. When we look at outages and incidents, or broadly speaking, there are three root causes for incidents, for IT incidents. It's either someone makes a change and breaks production. Second is you have unexpected system overload basically. And the third is something that you depend on doesn't work and you're not able to deal with it. Could be your cloud provider, could be an API. And in that case, it was a very unspectacular root cause. It was our core engineer making an upgrade of Kubernetes. Fortunately, it was very early in the morning, so all of our European customers, they weren't in the platform yet, and all of our US customers, they were sleeping. And this outage, this configuration change, this upgrade led to the Kubernetes master losing the connection of all their node groups. So there we were having all these nodes running, but not receiving any traffic. So everything was working, right? But all these node groups, they didn't exist for the Kubernetes master essentially, which took us some time to recover from it. But again, fortunately, it was no event ingestion affected, no notifications affected. But that was pretty intense, I would say. Yeah.
Yeah, I can feel that. The biggest question is, why does this always happen when you're on vacation, right? It's I had Ben Siegelman here also from Lightstep, and he had the same story, right? With his Code Red moment, he was, I think, partying at New Year, and on vacation, and the outage happened. So it's kind of weird that these things always happen when you don't really need them, right?
100%. We actually have a saying in the company, whenever I'm going on vacation, everyone is taking twice as much care as not to break things, because it actually we had more, I would say, issues, not outages, issues while I was away. But yeah, but for some reason those things tend to happen when I'm not here. So yeah, I guess one solution would be not going on vacation anymore, but I haven't tried that. I guess then I would have other problems.
Yeah. I agree. No, but that's good. Yeah, I mean, your company is headquartered in Cologne. I know the background that you're sitting. I'm in Solingen with my company. That's essentially, I don't know, maybe in miles, 15, 20 miles away. So it's pretty close.
Yes.
And it's so I'm glad to have you here, and also glad to have somebody nearby who's in the same space. I know you have been working for Rewe before, Rewe Digital.
Mm-hmm.
Who doesn't know Rewe outside of Germany is probably one of the biggest supermarket chains, right? Something like Walmart, or in mainly Germany. I think there are some international outlets too, but it's pretty big here. And they have a digital unit also in Cologne, and you were responsible there for a product, I think, right?
I was the chief product owner for all the big data products. And this was at a time when Rewe Digital, like the mission for Rewe Digital was to come up with like digital new business models. And one of that was the online grocery delivery, right? So and they did that, like I think they started doing it 10 years ago. And they realized that they need to own the customer experience, and they need to heavily invest in software. And I took over a department that was called like big data, and we were building like big data products for the entire Rewe customer journey, if you will. So these were things like a recommendation service. These were things like a service that makes sure that you have your the grocery items in stock at the right time, which is a different problem if you sell, for example, electronic items, or if you sell T-shirts. When you have perishable goods, the entire supply chain becomes a lot more complex. So that's what we were doing.
Yeah, and I know because you always also have been an Instana customer very early, one of
That's
our
true.
earliest Instana customers. I know that you were also very early on a Kubernetes stack using containers and microservice. So basically leading also on the architecture and new technology side of things for Rewe. So how did you then figure out that you want to build your own business and that it should be incident management? Was that based on something you experienced at Rewe, or?
Partly. So that's a long story. Actually, it has some personal elements as well. But I'll start with the backstory. So this was before Rewe. I was working as a student. I was studying, and I was working for different companies as a software engineer. In my final stages of my master's studies, I was working for the software company and doing my master's thesis. And I was doing research on like so-called context-aware notification systems. So these were notification systems that were supposed to be intelligent when it comes to answering the question, given a problem, who is the best person to handle this problem? And one recurring theme that I discovered during like my first job, my second job, and then like the final job while I was doing my master thesis was and back then the predominant solution that was used for monitoring was Nagios. One insight I had was if you have a problem, you cannot rely on email to raise awareness of the problem, right? You need a way that's more effective to notify someone about a problem. This was back then an SMS or maybe a phone call. And one realization I had was it was like pretty hard to make Nagios send an SMS. So there were these monitoring tools that were like, you could model everything. You could model dependencies. You have host service dependencies, and they were able to detect any issues. But when it comes to connecting those tools with the actual people that need the information in case of an incident, that was pretty complicated. So you either had to like set up your own hardware, your own modem that is capable of sending SMS, somehow connecting it with Nagios, and then having maybe like the phone number of one person in that modem. It was a mess, and I was like, okay, that's like, forget about this context-aware notification system that's supposed to be intelligent. Like my first insight was, let's solve that problem first. Like, let's make it very easy to send an SMS without reliance on any piece of hardware, without requiring like any complicated setup. And this was at a time where there were no APIs for everything. So there was like Twilio was, I think, just getting started, and they weren't available in Europe yet. This is how the actual idea came to be. And then during my time at Rewe, when I was working with different teams, and one of those teams was a platform team, and they were like responsible for operating 24/7 services. They were on call. And then this is something that I realized again, okay, it seems to be still a problem, although we were much better than what the situation was when I was doing my master's thesis, but it was still not really solved in our case. So that's why we teamed up with my co-founders, Chris and Roman, and then decided to go all into incident management.
So what is incident management? I mean, that's essentially the category, right? There's on-call. Is that part of incident management? Is incident management something different? Let's specify that category. I had JJ from Rootly on the show also before, and we also discussed it. But it's interesting to see that there are many vendors in that space, but they have different approaches, right, to to the category?
There are a few ways to look at incident management. And one thing we tried to do is, but we didn't succeed, is not label ourselves as an incident management solution, but instead an incident response solution. Because when you talk about incident management, like people would think, depending on who you talk to, like the first thing would be, okay, this is probably where I have ServiceNow. This is probably something I would solve with a Jira. In our domain, we're talking about real-time incident management. So really the first minutes to hours, all the actions that you take when you have an incident that are really time sensitive, and you're looking to stop the bleeding immediately, because you cannot wait for I don't know, like when it's super urgent, like you have to really like move fast and stop the bleeding. And what we cover is we cover everything during that cycle. And we like, one term that's out there is like the incident response life cycle, and it starts with preparing for incidents, responding to incidents, and then communicating incidents, because incidents, they rarely affect only IT, they affect the entire value chain. So you need to communicate with your customers, you need to communicate with other departments within the company and tell them that, hey, we're having an incident and this is impacting you as well, right? And so they can have their own business response. But and also the last phase would be learning from incidents. So if you look at the broader category of incident management, you have like these workflow-oriented incident management solutions like ServiceNow, who are like capable of like modeling your entire business, and you're setting up custom workflows. And then you have the real-time incident management. This is the part that we cover, and we call it incident response platforms. We position ourselves as an all-in-one incident response platform where you can manage incidents end to end.
Let's go through one of those incidents. So as far as I understand, you are basically doing a lot of integrations, right? We are just working on an integration with Zero too. So if we, as for example, Zero, we see a problem, we will report it to you, right? So our alert will go to you. And then what happens?
It actually starts a little bit before that, or before an incident happens. So when you like want to prepare for incidents, what you essentially want to do is answer all the questions that you have when there is an incident beforehand. So these are questions like, okay, for example, when there's an incident, the first question you ask is, okay, who is the person that can, like, which team is capable of fixing that incident? Out of that team, like, who is the person that is on call that I can reach out to now? And how can I reach that person? What do I do if that person doesn't respond? So these are things that you set up beforehand, but before incidents actually happen. And for that, you need to connect with the potential sources for that tells you that there's an incident. And one of those sources could be like observability solutions, monitoring solutions, like Zero, for example. And there are, it turns out, like even small companies, they don't have a single source. They have like 3, 4, 5 sources. And in big company, it's like tens, hundreds of potential sources. And our promise to our customers is whatever our customers are using, we integrate with that solution. If it's a source for critical information, we have an integration for that. And these are like usually observability and monitoring tools, but also ticketing tools. If you are a managed service provider, maybe you have something like an SLA with your customers. Whenever they raise a P1 ticket, you want to respond within an hour or so. And that would be a critical source of information for us. We integrate with that as well. Or you have like just a VIP hotline for reporting incidents, right? So again, when you are a managed service provider, you want to provide your customers with a phone number. And incidents, like despite all the sophistication and observability monitoring, there are quite some significant incidents that are still reported manually by a customer getting awareness of that incident and then calling whoever needs to be called, right? And we provide that as well. So that for us is also a source. So we do have, we provide a product that's call routing, where we are capable of routing incoming calls to the right person. So that's the preparation phase, right, of incident response. And then your actual question, so there is an alert. What happens then, right? So you submit like Zero, the platform submits a critical event to ilert. What happens then? So let's say it's 3 a.m. in the morning and I'm the on-call engineer. I get the page. I get a notification. Maybe I missed that notification because I'm sleeping very deep. And then I get a phone call from ilert. Ilert calls me and tells me, hey, there is a critical alert, reads out the text. and asks me to acknowledge the alert. The first thing I do is I acknowledge it, which prevents my backup from being notified. And then what do you do? The first thing is triage the alert. Like, is this an actual problem? Does it have business impact? Is this something that I can solve on my own, or do I need additional support? And let's assume this is a major incident. If it's a major incident, what do? Do you maybe like add additional responders because you need help from your colleague? So you log into ilert, you create situational awareness, you look at the alert, you see the information that is provided by -0. There are like links to -0 where I can like just check what's happening. I add my colleagues as a responder, and because this has business impact, at the same time I update our status page within ilert. From the alert itself, I say, okay, this has business impact, and this happens very quick because this is a stressful situation. We don't want to spend too much time on communicating incidents, finding the perfect message. It can be something like, okay, I say a short message like, this API is slow and it affects all our payment services, right? And then it crafts a beautiful message using an LLM, says, okay, hey, we're experiencing this outage here. You can expect an update in 30 minutes. And then I go on and try to fix the actual problem with my colleague. And then usually companies use the collaboration tools like Slack or Microsoft Teams. Again, this is orchestrated by alerts. You can spin up a dedicated war room channel. You collaborate on the incident. If you look at the alert, one important question that people also ask is, what has changed, right? Because usually, like I said, incidents, one major root cause for incidents are changes, and changes introduced by deployment, by configuration changes, like in our case. And we make that visible too. So we not only integrate with observability and monitoring solutions, build pipelines, CI/CD pipelines. Let's say you've connected your GitHub pipelines with alert, and then you're able to see, okay, you have this alert from -0, and in the meantime, there were, in the last 5 hours, there were these deployments from your team. Maybe one of those deployments has caused this incident, right? So we show you that information, and then at some point, you maybe decide to fix roll out a patch or roll back a deployment. And then, hopefully you fix it, you update the status page, then you're happy again, right? So that's how it works. Then after that, you would go to sleep, for example, probably. If it's 3 a.m. in the morning, you fix the issue. And then what begins after that is the post-incident phase, which you use for learning from that incident and creating maybe a post-mortem and agreeing on actions to prevent such an incident from happening again.
Yeah, makes sense. I have a few questions that came up. First is, how do you map the problem? You said you need to understand who's responsible for it, right? How do you map that? So if we as -0, we send you an incident for a service, I don't know, the ad service, how do you know who's responsible for that? Is that mapped out in the tool? Is it based on tags or information I have to send to you, or how do you do that?
Very basic way is to map it out manually, where you have, okay, whenever I have this alert source create an incident, it's that specific team that should receive these alerts. But then it could be more dynamic as well, where, like you said, in the payload of the -0 event, there is a field that says which service is affected. And so that's more dynamic in nature, right? Because it's part of the payload, and we can use that value to dynamically route the incidents to the right team based on the service that's affected. That's a more sophisticated approach. So that's one way we do it as well. And usually, when especially in larger organizations, every team connects their, I don't want to say own -0 instance, but they have their own connection to -0 where they receive just a specific, in -0 they would make sure just to receive a specific stream of events, of alerts, right? Where they know that these are relevant to my team, and they would distribute it accordingly.
And then one of the things I was thinking about is, okay, you call me 3 a.m. in the morning. I log into alert. I acknowledge the incident. I look at it and I figure out I need 6 of my colleagues to help me, right? Because it's a major outage, but it's 3 a.m. in the morning. So I create something like a war room or something, and then I can add the 6 people. And will you call them also for me, or?
You have an incident, the first thing you do is triage. And when you find out you need 6 colleagues, you add those 6 colleagues as responders. And in the background, ilert will do its magic and call those 6 people. Yeah. And you have created a war room in Slack, and it will not only call those 6 people, it will invite them to that war room. So they know which chat channel to join, and then you collaborate in that war room, right? And in the background, we record all the chat history. So later on, we can use that information to create a postmortem document, for example, because the chat history is essentially a gold mine for creating a postmortem document. It contains all the decisions, it contains all the speculation about root causes and so on and so forth. And we combine that with the machine-generated data, with the alerts, with the timeline, to create an 80% version of a postmortem document, for example.
I was thinking I need that for my family too, right? Sometimes when you don't know where everybody is, right? I use ilert and you call all my kids and bring them together.
And I think we were very good at that, because in ilert it's just a click, but in the background could be like ilert sending your kids an SMS, and if they don't respond within minutes, then sending them a push and then giving them a call and then another call, right? So yeah, you could do that.
Oh, that makes sense. And the customers are mainly larger organizations, also smaller ones. What's your typical customer for that kind of solution? It sounds like you have to have some sort of maturity in your process.
We work with large enterprises like IKEA, Avia, for example, as well. All the large MSPs like Bechtle, Bertelsmann, Data Group, Entity Data. But I wouldn't say you have to have a large team in order to benefit from ilert, because even if you're a team of 2 or 3, 4 people, whenever there's on call involved, whenever there's more than one person, because if it's just one person, if it's always the same person, then probably having a solution like ilert would be an overkill. We make it very easy to get started with ilert, even if you're a team of 5 people, for example. We have a free plan as well, where teams of up to 5 people can use us for free. And I would say once you have more than one person and once you have more than one potential source for critical events, then you probably need a solution like ilert.
I always have to go to that topic at the moment. It's the AI topic. You said there could be an LLM getting a better message for your customers, but how do you see LLMs working in that space? Are you using them today for ilert, and how do you see that going forward?
We make heavy use of LLM-powered AI functionality. Like one is, and this is a very or 2 of those use cases I just talked about, creating incident messages. That's probably, if you wouldn't provide that in the platform, that person would probably go to ChatGPT anyway and just type in, "Hey, I want to create a message. Can you make it good looking for me?" And we make it very easy by you just click a button and then it selects the services that are affected. It understands the intent. So that's I would say one use case that's very straightforward, but the overlap is also very high in the sense that it's useful, right? Because you want to draft a message and then you make that very easy and you see it right away. You would discover if there is some sort of hallucination. So that's a clear fit for us. But then, or the post-mortem generation that I just talked about, that's also an area where we think that's LLMs are basically not responsible not to use LLMs for drafting this post-mortem document from this huge body of text, right? So these are 2 areas, but there are also other areas where we work with LLMs. Like one is intelligent alert grouping. So when you have alerts from multiple sources, and we use, for example, those text embedding models to understand the intent, the semantic meaning of an alert. And for that, we host them on our own. We're not making a call to OpenAI, to Anthropic or Bedrock or whatsoever. So we host these text embedding models on our own. We vectorize all the alerts that come into our platform, and then we compare those vectors, those alerts that happen within let's say a time frame of 5 minutes, and then we're able to correlate them, because alert fatigue is also a problem. When you're being flooded with alerts, you end up with too many notifications, too many distractions, and this impacts your ability to any minute that is taken away from you that you can spend on resolving the incident is a minute more in MTTR, right? And that's what you're trying to reduce. You're trying to reduce MTTR. And this is an area where AI is also very helpful. So we have not only message generation, post-mortem creation, we also have intelligent alert grouping. So there are a few areas where you're already using AI to improve the user experience.
when you talk about MTTR, right? I like that metric, but it's actually not that easy to measure. But you could probably, right? Because you know when an incident appears, you know when it probably you have to close it in your tool also when you're done, right?
Exactly.
So you basically know how long does it take until somebody really acknowledges and responds. And then you also know how long it takes basically to repair, right? Is there any statistics you can share with what you have learned over the years with so many customers? How long does it take that somebody responds to a problem, and how long does it take on average I mean, I can see that it varies, right? But is there some kind of rule of thumb where you would say, oh, the best? I love the DORA report, right? DORA always says, hey, there is the best teams respond in that time, and it takes so long, and then there is like the some that don't have the process in place. So do you have any kind of guidance? What is a good timing here?
We actually have something in the works where we want to like use our own data just to come up with a report that shows, okay, this is how like these core KPIs like MTTA, MTTR across different industries, and like what factors contribute to like a good MTTR and an MTTA, and what factors affect those KPIs negatively. I think thirdly, my response would be when it comes to MTTA, you want to like we had companies, like even really large companies who manage a critical, and that specific example is this is a large managed service provider who manages a critical infrastructure of an automotive automotive customer. They had MTTAs, so the time between something is reported and the human is working on it of up to 2 hours before they introduce ilert, and then they were able to bring it down to less than 10 minutes. And now you might think, okay, like how can this happen like after 2 hours? But it's like depending on the way like the communication channels, incidents alerts are reported, and depending on like how many people there are involved, that can get very like you can reach 20 hours really quickly. Like if the first instance misses an alert, then you have the next escalation maybe after 30 minutes, and that one's not effective too, and so on and so forth. So yeah, to answer your question, I think like a very good MTTA is probably in the minutes, like less than 10 to 5 minutes, and of course MTTR hopefully always less than an hour if it's something that is business critical and has business impact. But we're working on a more structured report based on our own first party data.
Well, I can already see that, right? I mean, just waking somebody up at 3 a.m. in the morning could take some time if you don't have an automated solution, right? And going down that escalation path and getting from 2 hours to 10 minutes or 5 minutes, that's a big difference for your business, right? Especially if it's business critical. Yeah. So that makes sense. And how do you make sure, that's another question, because you said, yes, you had an outage, but especially I know when it comes to communication, that's not always that reliable, right? How do you make sure that you can make the call? I think that's very important for you, right? That are you using multiple providers, or how do you? I mean, probably you're using something like Filio or other APIs.
When you asked me about our code red moments, the one thing I didn't mention is that the way it was like for us was like somewhat shocking is but because we put in like so many like measures of reliability. So basically, reliability was a feature from day one for us, right? So we had like multiple regions. Back then we had like multiple availabilities, but now we're deployed across multiple regions. So we had redundancy at the infrastructure level, database level, application level. We have a redundancy at the provider level. So we don't work with one provider for making phone calls, sending SMS. We work with 3 providers for every notification channel. So and that was one reason why like this particular incident hit really hard, because it was like you had so many actions, but then it boiled down to a very simple like mistake during an upgrade process, right? Despite having all these levels of redundancy. But yeah, to answer your question, we have provider level redundancy, we have like data center level redundancy, we have like the application is architected in a way where when one part doesn't work, it doesn't affect the other, the remaining parts of the application. So yeah, that's a big, let's say, like a core feature of ilert is availability.
I can see that this is really important in that case, right? Because you want to get that response quickly. And by the way, I think outages are, I can tell you also from, as an observability platform, we have the same. I'm always very worried. It always happens, right? You can't,
Yeah.
it's IT. And the funny part is if you look at things like the outage with CrowdStrike or Datadog had the large, I think almost 24-hour outage. I think there
Yes.
was also a Docker image update and it's always some sort of, as you mentioned it, some sort of change, some simple, I just have to update this version of my Kubernetes or this thing. And then something very weird happens, right? That's something you can basically not really prevent. Somehow, yes, right? If you have multiple regions and things, you can make sure that these changes are rolled out only in one region. And once it works, it goes to the second. So probably you have also now very high sophisticated rollout strategies, I can imagine.
Yeah, after this incident, for sure. But there's a reason why there's a saying, never touch a running system, right? So you asked about how can you prevent outages in general? One way could be you don't make any changes. But the problem is if you don't make any changes, if you don't touch your own system anymore, your customers will stop touching your systems either, right? At one point, because you get irrelevant. So what we recommend is embrace the fact that incidents will happen, but prepare for incidents. Accept that they will happen, but try to limit their business impact. And if it hurts, do it more often, right?
I always remember there is this famous SRE, site reliability engineering book from Google.
Yes.
And there is this passage where they describe, I think the service was called BOC, right? A centralized lookup service for services. And that had 99.999 whatever percent availability. But they had downtime of around 15 minutes per year. But because it was a centralized service, that affected all the Google services. And what I found interesting, so the way they fixed it is by making sure that they shut down the Borg service every day.
Yeah.
And at first you think oh, why, right? But the problem is, and I know that when I started, I used to work and there were mainframes. And if you as a developer, you think something is always there, you start programming like this, right?
Yeah.
You don't have the failure, right? But if you know, this Borg service, that goes away every day, you program differently, right? Then you start saying, I can't rely anymore that this thing is there. And then same what you said, why are you using 3 APIs for your messages? Because it could be that one of those message servers, which is probably also very rare that it really doesn't work. But if you program in a way that you rely on it being there, it's very different to, I don't rely, then I have to have a fallback, right? I have to say, try this. If it doesn't work, try it again. If it doesn't work, then take the second service, right? And that's how they fixed the problem with Borg. It's basically by shutting it down more frequently. The developers had to totally change the way they're using that service.
You're basically telling other people that depend on the service, don't depend on it being there all the time, right? And that was the third category of root causes I was trying to explain in the beginning. One root cause for incidents is something that you rely on breaks, but you have to architect your systems in a way where you expect failures to happen for your dependencies. And I wouldn't even say that you have to design the system in a way that you have a fallback. The best approach is probably having an active setup. For example, we have 3 providers. They are not primary, secondary, and tertiary. We use them all 3 all the time. Because a fallback strategy always assumes that you have this one standby service sitting there. First of all, you're probably not a good customer if that service is only a standby service, because they would only make money from you if your primary service is experiencing an issue, which is hopefully very rarely. And secondly, it's also better from an engineering perspective, because a fallback scenario is also something that's very intrusive, because from one point to the next point, you're redirecting all the traffic to a service that was sitting there that didn't receive any traffic, and then all of a sudden takes all the traffic, right? So that rarely goes good, I would say. Similar with when you have a database replication across multiple regions, and then you have a fallback. Most of the time, that fallback is not as smooth as you would expect. So therefore, we think it's better probably to always distribute your traffic across multiple, like either APIs, multiple regions, and have an active setup instead of an active passive setup.
I have one last question, because I saw that you say that you are also a DevOps tool, right?
Mm-hmm.
And I would like to understand how you think about that term today, DevOps, versus developers, versus SRE, versus the new hype around platform engineering, right?
Yes.
How do you see that term, and how would you position ilert in the context of developers and platform engineering, DevOps, SRE?
Probably like not good at like defining those terms, DevOps, SRE, and like platform engineer.
Me neither, by the way.
Yeah, they are like they somehow overlap. But the way like I look at it is, and probably this applies to you as well. Like I have a career long enough in IT that where there was a time where you would build a piece of software for 6 months, a year, or for a year, then you would hand it over to someone else, to another department, which is called the operations department, and they would have like steps to execute to deploy that software. Like literally, that says, open the terminal, type in this command, and do this. So that's the exact opposite of DevOps, right? So that's where you have like operational responsibility completely separated from the build responsibility. And when you have a DevOps lot of operation, first of all, you like see the problem of operations as or the task of operations as a like software task. So you try to code as much as possible and automate as much as possible. And you get to like experience firsthand when your software is not a good citizen in the world of operations, because it's you who gets the pages. And that's probably one of the most effective ways of making your software more reliable, when you experience it firsthand when it's not working. It's a little bit similar, like you said, with the example with Borg and the Borg team designing that service in a way where other teams have to expect that this service is not available once a day, right? So they could feel and they can prepare for it. And that's similar with DevOps. And not to answer the question, like how do we fit in that like solution? Why are we a DevOps tool? Because like in a way we adopt like many of these like practices. For example, we have a Terraform provider where you can codify all your like incident response related activities in Terraform, and apply the same automations and version control techniques that you would use in a DevOps environment. And of course, when you have operational responsibility in a DevOps team, you need a solution that brings immediate human attention to problems that need immediate human attention, and that's where we come in.
It's a good answer. Thanks, Birol. It was nice having you here. It was fun talking to you.
Absolutely. Thank you, Mirko. It was a pleasure talking to you.
Thanks for listening. I'm always sharing new insights and insider knowledge about observability on LinkedIn. You can follow me there for more. The podcast is produced by DevZero. We make observability easy for every developer.